In this video series, we've been trying to figure out how, in the heliocentric model, a person on the terminator line can see both sun and moon on his horizon at the moment of peak new moon, instead of a couple hours before or after peak new, as this observation shows. The reason we can't is that our line of sight from terminator line to the sun is different than our line of sight to the moon, since the sun is 400 times farther away. So at this moment, a couple of hours before peak new moon, Jane, who is at the terminator line down here, can see both sun and moon on her horizon. Bill, who's at the terminator line up here, is still about 4 hours away from being able to see both sun and moon on his horizon, because it'll take that long for the moon to travel to Bill's horizon line. Keep in mind that we have Bill and Jane traveling at the speed of the Earth's rotation, so they remain on the terminator line at opposite sides of the Earth. So a couple of hours after Jane saw sun and moon on her horizon, and was therefore in the eclipse shadow, the moon has moved to peak new position. At this point, people experiencing high noon are the ones seeing the moon aligned with the sun, and are therefore in the eclipse shadow. At this point, Bill and Jane can still see the sun on their horizons because they remain at the terminator line. But neither of them can see the moon because they can't see around the Earth. Well, at least not to that degree. And if they could, they'd be experiencing an eclipsed sun rise or set as the Middle Earth people are experiencing their eclipsed sun at high noon. Then, another couple of hours after peak new, Bill is finally able to see both sun and moon on his horizon and experience an eclipsed sunset. At the same time, Jane is now 4 hours removed from her eclipsed sunrise. Now, to be sure, globe proponents have certain rescue devices they employ that muddy up the waters. They imagine we can see to a certain degree down to our horizon, a certain degree around the ball Earth, and that refraction causes the sun and moon to appear somewhere other in the sky than where they actually are. So I ended my last video with this question. Adding all the refraction and dip angle that you deem realistic, what is the minimum amount of time before or after peak new moon that a person standing up on the terminator line at sea level within 35 degrees of the equator could see the sun and moon rise or set together? Hubert responded, "In this video you show an example where the new moon and sun rise exactly at the same time at the terminator, but not during peak moon, but 1.5 hours earlier and later respectively. I also agree with that. The moon has to move around the Earth by half a degree to a full degree to move from or to peak moon to the place where it blocks the sun for an observer at the terminator line. This corresponds to a time difference of 56 to 108 minutes. Ruhif came up with his answer of 54 minutes as the minimum, and he based that on 35 degrees north or south of the equator. So I'm assuming he will agree with Hubert that it'd be closer to 108 minutes at the equator. Of course, 108 minutes is an hour and 48 minutes. So Bill and Jane, from their respective points on opposite sides of the terminator line, are each a minimum of an hour and 48 minutes from seeing that peak new moon on their horizons, assuming they are on the equator. So while it took a while to go through the tedious process, it seems we are all pretty much on the same page now. So how does this concern the heliocentric model? As in that model, peak full moon is the equal but opposite alignment of peak new moon. So if Bill can see the sun on his horizon here, but it'll be a minimum of an hour and 48 minutes before he can see both sun and this peak new moon on that horizon, then he's also an hour and 48 minutes removed from seeing the sun on his western horizon at the same time he sees the moon on his eastern horizon. Naturally, the same goes for Jane, who can see the sun on her eastern horizon here, but will have to wait about 2 hours after peak full moon before she can see both the sun on her eastern horizon and the moon on her western horizon at the same time. So enter Exhibit A. On March 20th of this year, I noticed that the peak full moon was going to be above the horizon before the sun set, near my home at 33 north latitude. You can see that the moon rose at 6:35, and the moment of peak full moon was 7 minutes later at 6:42. The sun didn't set until 6:43, meaning that both sun and peak full moon were on my horizon at the same time, when it should be a minimum of 54 minutes after peak full before I could see both sun and moon on my horizon. I tried to capture some footage of it, but it seemed like everything was conspiring against me. I ended up working late, so I had to drive 2 hours like a maniac through rush hour traffic to get to a workable spot, while major storm clouds were blowing in, threatening visibility. Rich was planning on helping out, but his migraine left me on my own. I wasn't able to get as far west as I would have liked to, but time was running out, so I couldn't be choosy at that point. Then when I got there, I had to have some heated words with a javelina who wasn't happy about me trespassing in his territory. Anyway, I finally ended up with these time lapses. And wouldn't you know it, after all that, I ended up having one of the cameras pointed in the wrong place. Yep, I was aiming over here, and the moon rose over there. Not that I would have been able to see it well through a mountain and all those clouds anyway, but based on how high it was when I finally saw it, and how long it had been since the sun disappeared, I'm confident that the peak full moon was indeed on or above the horizon while the sun was still visible. So I went to Stellarium to see what it looked like there. Peak full was at 6:42 p.m. my time, which is 1:42 a.m. UTC time. And my task is easier using UTC time for all events. Note that 6:42 p.m. on March 20th Arizona time is 1:42 a.m. on March 21st UTC time. You'll also notice that I moved Stellarium Guy down to the equator from 33 north, because that makes the minimum time between peak full and seeing the moon on the horizon with the sun an hour and 48 minutes instead of 54 minutes. So according to Ball Earth math, and even allowing for dip angle, this angle, that angle, and refraction, Stellarium Guy should be an hour and 48 minutes removed from being able to see this sun and this moon on his horizon. And to make matters even worse, Stellarium Guy's antipode twin is also seeing the sun and the peak full moon on his horizon from the opposite side of the Earth, when he should also be an hour and 48 minutes removed from seeing such a thing. And this isn't some fluke, once-in-a-lifetime alignment here. This happens every peak full moon all along the equator. You only need to find the longitude that coincides with sunset and peak full, and you'll see that a person there will see both sun and peak full on his horizon, while a person at his antipode will also be seeing sun and peak full on his horizon at the same time. Here's the very next month, and you can see that peak full is at 21:11 UTC time. I just used Reykjavik for the peak times because Iceland never deviates from UTC, unlike London, for instance. And here's what the moment of peak new looks like from on the equator at 48 west longitude. You can see the peak full moon is rising in the east while the sun is setting in the west. That moon is an hour and 48 minutes out of heliocentric alignment. And here's the antipode location, where the sun is rising in the east while the peak full moon sets in the west. Now, before someone brings up that the sun and moon aren't perfectly bisected by the horizon, let me point out two things. Firstly, I only use the term perfectly bisected to avoid any petty diversions caused by the bigger-than-all outdoors sun you required me to use. Stellarium doesn't use your mega sun, and so sun and peak full being on the horizon together is enough to make my point. Secondly, is nitpicking really going to help when the moon is a minimum of an hour and 48 minutes out of heliocentric alignment? Oh, and by the way, I could play with the longitudinal minutes and seconds until I found the exact spot on Earth where peak full and sun were perfectly bisected by the horizon. I just didn't feel it was necessary to expend that kind of effort when the point is being made without it. It just dawned on me that I skipped right over April, so here is peak full UTC time. Here's sun rising and peak full setting at 77 west longitude, and here's sun setting as peak full rises at 103 east, the antipode. Jumping to June, here's the peak full UTC time. Here's sun rising while peak full sets at 37 west, and here's peak full rising while the sun sets at 143 east. And finally, here's the UTC moment of peak full moon for July 2019. Here's what it looked like from 127 east as sun rose and peak new moon set. And here's what it looked like from 53 west where peak full rose as the sun set. Hopefully you can see by now that I could do this all day. And hopefully you can understand that if this peak new moon is an hour and 48 minutes from being seen with the sun on either Bill or Jane's horizons, then the same must be true of peak full moons. And we know it must be true for peak new moons, otherwise we'd actually have the Middle Earth people, Bill and Jane, all seeing an eclipsed sun at the same time. Not to mention all the people on the eclipse path in between them, right? In other words, the entire day side of the Earth would see a solar eclipse at the same time, and this would go on for hours. Now, since peak full is indeed the equal but opposite syzygy alignment of Earth, Sun, and Moon in the heliocentric model, what's good for the goose must also be good for the gander. So if Bill and Jane are each an hour and 48 minutes from seeing this peak new moon on their horizon, then they are likewise an hour and 48 minutes from seeing this peak full moon on their horizon. Yet observation and heliocentric software tell us that the former works in the model, but the latter doesn't. And we haven't even gotten to lunar eclipses yet to see how they play into all of this. We certainly will, but I'm going to stop it here for now and see what kind of rebuttals we get before moving on. Thanks for watching, and I hope you guys stick around because there's still a lot of stuff to come.